All right. So we're going to go right into all of this stuff because my goal today, we'll see how well we do, is I want to finish up talking about module section 5. And you'll say, why are we talking about section 5 still? I just really want to make sure we talk about those parts since you're going to be using Pandas a lot. I'm just kind of point out a few things that will be something that you come across relatively frequently. And then talking about data cleaning, which we really haven't talked about yet, at least in study group. In the curriculum, you've probably gone through at least parts of it, but it's kind of important to kind of say like, okay, what are the common things that you would do to explore and actually do data cleaning? And then a little bit after, we'll actually introduce visualization. So data visualization, now, anyone who, just give me a thumbs up, who's in section 6 or have at least touched section 6? Maybe you kind of like looked at it really quickly, maybe you finished it completely. Awesome, cool. All seeing thumbs up, that's great. So we'll talk about section 6. We'll probably only do these 2 notebooks here, the motivation of data visualization and how to use visualizations. And then I have a little surprise for you guys to do a little activity, which will be fun. So we're going to see if I can actually get through all of this. As you guys probably have seen, my timing is not always the best. And then next time, my hope is that we'll actually finish up with some good and bad visualizations, some detail where basically I can start ranting and stuff like that. And then we'll talk about section 7 as well, like afterwards about SQL and different SQL exercises and stuff. Okay, sound cool? All right, so let's get right into kind of finishing up what we had last time. So we talked about NumPy to Pandas. So we talked about NumPy and how it relates to Pandas, you know, how it's kind of basically, Pandas is kind of like a wrapper for NumPy. It actually has a little bit of extra stuff too, including like, you know, matplotlib, which is pretty nice. So we're gonna kind of skip through a lot of this. I'm just gonna expand everything. There we go. So we talked about, you know, like what a series is versus a data frame. This is all the code we saw before, right? So nothing too unfamiliar, right? Yeah. So we also talked about how you can have data files from like a CSV file, an Excel file, JSON file, which we'll talk about, I think, next week. So you can load all these things in as well as export them out. Typically, when we're using Pandas, we'll probably have something like a CSV file and have to load in that data. But there's other methods too. And then I think I very briefly just mentioned about a def function versus a lambda functions. I think I mentioned this like, I don't know who I've talked to already about this every single time, but a lambda function really doesn't have to like technically you could go away your whole life in Python and Pandas and data science and never ever use a lambda function. It won't necessarily be fun, but you could do it. Like it'll work fine. It just makes our life a little bit easier, but usually you'll see lambda functions used in like .map, .apply map, and a few other things like list comprehensions and stuff. Okay. The main thing to know is that your lambda function basically is like a one-time use function. You're like, I just need to use that function right then and there versus having to like define a function and then applying that function somewhere else. I'm kind of like looking like higher up in your notebook. And the reason why we do that is like if we want to change that function like in our list comprehension, instead of like saying, oh, there's calling this function, we have to go find where we define the function way up somewhere else and then change it up. We can just change it directly in here since it's a lambda function. Okay. Pandas methods, we talked about this, like some other things like as type, so we can actually change the type to date time. This will be really special for like time series. Doing a rename, this will rename the columns. Dropping stuff, so you can actually drop columns or dropping rows. Stuff like this can be useful, like if basically there are mistakes in the data or basically data that we don't really need. And then set index, I think this is more like about like, this is especially useful in time series where our index is basically the way we count, you know, like what is a record. And if you have something like time series where it's like, oh, it's very special to keep track of what time, whether it's a day or it's a month or it's like, you know, a second in time, you can treat that as an index. Okay. So I think that leads us to about where we are right here with assessing data. Okay. So I'm actually going to close these guys so we don't go too far in. All right, so right here I'm actually using something called SKlearn. Have we seen SKlearn before, like in the curriculum or otherwise? No, that's all right. SKlearn will get more into detail, but basically it is typically used for machine learning in Python. It is really useful. It also has some built-in data sets, which are really useful to kind of play around with. So like, you know, like, oh, I just want to kind of play around with these features without having to find a data set. We can actually use SKlearn to get this stuff. Okay, so you'll actually see I'm loading in a data set called load. Sorry, it's about wine basically, and you see here importing in Pandas. So data equals load wine. This is basically a function specific for SKlearn. So if I actually run this, and I'll show you guys the little tab, shift tab. You guys all know shift tab now at this point, right? Well, no, perfect. Okay. You can see load and return the wine data set for classification. And it gives me a whole bunch of information. For example, there's 3 classes. Basically, there are 3 different types of wine. How many samples there are per class, you know, how many samples in total. So, okay, so that's 59, 71, and then 48, and then 178 in total. So, and dimensionality just means how many different features there are. So I'm just loading this in so I don't have to go find a data set. So I'm actually creating this data frame. Generally, you might not do this. You'd probably just use like a import from CSV kind of deal. But you can see here I have this data. I'm just getting the data and then specifically calling these columns. So just to kind of make things really obvious is if I do data.data, you'll see this is all data. You can see here, hey, array, what does this mean? What kind of type is this whole thing? Someone unmute and tell me.
Array.
An array. What kind of array? Starts with an N.
NumPy array.
Yeah, NumPy, NumPy. I usually say NumPy. I know some people call it NumPy, but they're wrong.
NumPy.
No, I'm just kidding. No, but that's an old argument me and Eli would have. But anyway, so yeah, it's a NumPy array. So good. So you can see here, it's like, this is not a data frame. It's not reference nice. We're going to see a whole bunch of things in here. Also, if I do, let's see here, feature names. So you'll see I load feature names into here. You can see here, these are actual names of the features. So these are like, you know, alcohol, malic acid, ash. I'm no wine person, so I have no clue what some of these things are. But you can see here a little bit of different column names. So if I load this data frame here, df.pp.dataframe, I loaded in the data, which is the NumPy array, and I load in the column names, which is this guy right here. Yeah, I didn't have to do this part, but it makes it nice and convenient because then I can see what the columns are. All right, so now it's like, okay, cool. I got my data frame. Now what? Like, why did we do this? Why couldn't I just use the NumPy array? And the data frame basically allows us to do some extra methods to kind of help us organize our like flow as a data scientist. So you can see here I have like .info, .describe, .head, .tail. These things are basically to very quickly go through a data frame and basically observe some interesting parts of it. These are not all the methods you can use, obviously, on a data frame, but they're usually ones like, in general, I'll use .info, .describe, .head. Like almost every single time I import data, I don't even think about it. I do those 3 commands. So we'll see what those 3 do. So it's .info, takes in my data frame. So it says, hey, it's a data frame. And you can see here, it tells me, oh, there's 178 entries. So that means 178 different rows, right? And you can see here, it's like, okay, there's alcohol. These are the different column names right here, alcohol, malic acid, ash. And you can see here, 178 values that are non-null. And it also tells me what type it is. So there's float 64, there can be int. There's also object, which I will tell you right now is that probably in the next, you know, I mean, it depends when you start working and stuff like this, but Pandas 1.0 allows for not object type, but string type, which is actually really convenient. So this could also be string in the future too. But the idea here is to give you the type, okay? And non-null, what is null? You got an idea?
Not a number.
Not a number, but it's a little more generic than that.
Missing data.
Yeah, it's basically like empty data, which can be not a number, right? If it's missing, it's obviously not a number, but it can also be a string, right? Which is missing information, it's just null data. So this is why it says non-null. So, okay, there is no missing data, at least for each of these rows, because remember there's 178 entries. Sometimes you'll see that actually missing here, and we'll see this in a later example. Okay, cool. Everyone got this so far? All right, awesome. And you can see your memory usage too is really useful because Pandas actually loads in all of the data into memory, which means basically like it's using your RAM. So if you have a data set, which, you know, you're going to be like, what? Like 100 gigabyte data set, you can't necessarily just load that directly with Pandas. You're going to have to do some extra stuff or use a different package. So it's something to kind of be useful to know about. All right, so df.describe, this is actually a really useful one. This one actually shows us now. In this case, this is all the columns are numeric, but if they're not numeric, if they're categorical, like they're strings and stuff like that, imagine like color was one of these, you know, columns. It wouldn't have a number. It might just have like, you know, like red, white, or whatever. This will actually tell us though, for numeric columns, some interesting statistics. So we can see like the counts and like how many are in there. It tells us the mean value, the standard deviation, the minimum, the maximum, as well as the different percentiles, right? So this basically is representing, you know, if you remember your interquartile range or your box plot kind of deal, that's what these numbers are representing. Okay. Cool. And so this is really useful because then you can very quickly tell, like, for example, if something's skewed off to one side, like maybe there's a, like all of a sudden there's a huge spike, but most of the values are relatively small. This can give you a very quick thing. I personally don't like spend too much time on .describe unless I know like specifically what I'm looking for. I'm someone who really likes doing visualizations to basically like see those because I feel like it's a lot easier to see that. But it's a useful thing if you're kind of exploring parts. Okay, so cool. Any questions on this df.describe? So pretty good. All right, cool. And then df.head, this basically just gives us the first 10 values. Note that on here it says like 0, 1, 2, 3, 4. Okay, the reason why we do df head is, does anyone know what happens if I do df? Will it just show me everything? I'll try, right? Yeah, so you can see here it goes 0, 1, 2, 29, and then, hey, it skips a whole bunch, right? And then it goes up to the end here. And you can actually see the very bottom here. So you can see this is a kind of a little frustrating to like go through a little bit. And really when we do df.head, we're just like, hey, we just want to get a feel for like what the data looks like. And that's really what this df.describe, df.info, df.head, we're just getting a feel for like, what are the data looking like? And that's really like what exploration really is. So df.head allows us just to basically get those first, I think, default 5 rows. We can also default to say, okay, let me get the, specifically the first 10 rows. And you can see here, goes in this. Okay. And then tail, as you can probably guess, does opposite. It goes the last 5 rows, or if you put in like 10, it'll do the last 10 rows. Sound pretty good? All right.
I have a little share.
Yeah.
Awesome. On the summary statistics, maybe people know this already, but at the end of the describe, I put like .round and then 2. And I found it's like way easier to look at for me. I don't know if anyone else is like that too.
Yeah, that's a really good point. Thank you for sharing that.
Yeah,
so you can see here, this will basically, this .round 2, as you guys can probably guess, it rounds it up by 2 decimal places. And so that can be really convenient for you. Depending on like what the data look like, you might not do this by default, but it might be still something useful. To be honest, in general, I usually don't go off of df.describe too quickly. Like I just kind of like look at it really quickly and see if there's anything interesting. Like if I'm just kind of going through here, for example, you can see like really quickly, like, oh, the max is like pretty significantly higher than like even the 75 percentile. It's like twice as much. Like, oh, like that means like there's some extreme wine, like some outlier wine. So like if you think about like this in age, you might see ages like, let's say like 12-year-olds, 25, let's say 40 years old. And then all of a sudden you get like to like 110, right? You're like, oh, that kind of gives you an idea of what the data looked like, versus if you had something like the minimum is like closer to like a small value and stuff like that. But this is where like I say these are initial parts. So do whatever you can that kind of helps you get a feel for what specifically you want. Okay. Well, thank you for sharing that, Jessica. All right. So let's check out some attributes too. So this is where I didn't go into full details on this. You can kind of play around this. You can do the .index. You can pull just the index, just get just the columns. So you have a data frame. This case, it's kind of redundant because I defined df, what is it up here? Yeah, I defined the columns myself. But if you read it from a CSV, it'll try to take these columns and automatically you can do the .columns and that will actually give you a list of the column names, which is really convenient sometimes. Dtypes, .shape. .shape basically just is telling you the overall look of the data frame. So for example, if I do like df.shape, you can see here, it's just very similar to like a NumPy array. That's telling me, oh, there's 178 rows, 13 columns. Okay. And then there's .lock and .ilock, which are basically choosing specific parts by column or by index. Right. For the record, you might see sometimes people use like .ix if you like pull like up some old code or an article. Don't use .ix; it's deprecated and everything like that. You should use .lock or .ilock if you're doing that. Okay. Cool. All right, I'm going to move quite a while along. All right, pretty close. Just no, I put some additional resources, stuff like this. I think the more you just explore things and what you're like interested in doing, like for example, it's like, oh, can I do this? Just Google that, whatever you're trying to do, and see what comes up. But anyway, this can be useful. Just know that the attributes don't have necessarily any what's it called, parentheses at the end. You're not calling a function on top of it, and that's really what the method's doing. This method is basically a fancy way of saying a function it's basically taking the data frame and using a function on that data frame. An index, or sorry, not index, attribute is something that is like a property of the data frame. So like the columns are a property of the data frame. So just kind of know that difference sometimes. Okay, cool. All right. So one thing I want to note is Boolean masking. This is what I would reference it as. Has anyone seen like what something like this does? And actually, I'm gonna. Yeah, I see some nods. So just looking at this, can someone just explain to me, what do you think this would do if I were to run this?
It gets all the columns for alcohol. I mean,
it
gets the column alcohol and all of its rows.
Yeah, and there's something specific in this, right? Is that it's something beyond just alcohol itself, right? So like I should say like df.alcohol. Oops. Gives me all the alcohol, right? Like that's a series. But what do you think? Like this part is the part I'm kind of interested. What does this do?
It's going to give you the locations where the alcohol value is less than 12. Yeah. It'll say, yeah, true, right? Or the locations.
Yeah, that's actually something a little bit better. I think you're thinking, I think that was Jessica, right? I think what you're looking at is like, okay, DF alcohol less than 12, right? And this will actually return, like you said, a series that is true, false, or whatever is less than 12. So for example, the first two values are 14, 13, 14. So I think that the first time, ooh, it's pretty far down here. Let's hear. The first time you should see true is 20, oh, not even 23. Yeah. Oh, well, we're just gonna run this. We'll say true, false, all that stuff. Is there even any true in here? Oh, you can't see any truths. But the point is, it's like, oh, alcohol less than 12. Let's say it's less than 14. And you can see here, the first one was like 13 or something. So this basically is giving us a true, false. Like, oh, that's kind of nice, but like, I want to know what the actual value is, right, for that specific row. This is where we can actually use something like this. And this is basically using like a mask. So I like to call this being like your mask. And I can just set this equal to mask like this. And I can say, all right, df mask. And this will basically only get, if you notice, like, for example, it skips the index 0, skips the index 3. It's only getting the rows that are specifically having alcohol less than, in this case, 14. If I did 12, this will be even smaller. So you can see here, it's a relatively, like, pretty small rest of the data frame here. So this can be really useful to say, okay, I want a specific, I'm only going to look at the wines that are very low alcohol content, and what are the other properties of that low alcoholic content wine. Okay, does that make sense? Okay, cool. So then from this part, you're like, okay, cool. Like I can do a lot of stuff. And note that I have like mask here, but I could have done the same exact thing with just putting it directly into here. And note that I have .lock. I believe you can just take off .lock here and do the same thing. So you can reference it in that same way. And just know that technically this is just basically producing a series that is just true, false, true, false, true, false. Okay. If I wanted to do something, I could create like a series of whatever I want. But the point is that this is creating a true, false thing. And then I pass in that series into my data frame, and that will give me the rows that I want to care about. Okay. Cool. So just kind of seeing a little bit, like you can see alternative way I did it like up there. I like to do it this way because it's a little bit easier for me to read. So basically I call this mask. Basically it's like what things I actually care about, and then actually passing that mask up to the data frame. You can see that's what it pulls up. If I wanted something like, say, okay, I want the alcohol that's less than 12, but greater than 11.7, right? You can see here, and normally in Python we use the word and, right? And to do like multiple conditions. In Pandas, when we're looking at a data frame, we have to use this this ampersand icon. I won't go into the full details of why this happens, but basically just knows it has to treat it in a different way. So the point is that you would have to use this and. So note that I can make this whole thing as a mask. I could have also just kind of copied this and put this directly into here and work the same. So this will basically only pull up the things that are less than 12, but also greater than 11.7, which you can see here is going to skip 74, but it's going to get, oh, no, sorry, it is going to get 74, but going to skip 75. So if I run this guy, we should see, there you go. See 74, but it skipped over 75, 76. Well, 76 was already skipped over before. Okay, so you can get some like pretty interesting things here. Note that I also have, in this case, alcohol. I can use the OR operation. So this OR operation, just like, or in Python, basically it's like it's less than 12 or it's greater than 14, right? And I can run this guy. You can see can get different results now. Note that I technically don't have to use just, I'm using alcohol as that column each time. I could change it to like, let's say ash, and have it like ash is greater than, let's say less than 2. So this will pull up like multiple parts. So you can see here is that now I can get different results. And this is because this is going off of this guy and this guy. So this has to be evaluated to true in order to show it. Okay. So pretty good. Cool. I believe also you can also do not. So this is the icon for not when we're talking about like these. If you want to know, it's called the bit operator. But basically, this is what we have to use specifically for data frames. So this is like, if you notice this is not, if I take this guy off, we should see, instead of 0, 1, 2, we should not see those ones. You can see, there it goes. Okay. Sound good? Thumbs up? Any questions? No? Cool. All right.